multiplexer using a 2x1. Okay, here in module I have taken a gate level multiplexer. How can you take a gate level multiplexer? First, you will take a 2x1 multiplexer which has two inputs, one selection line and one output. Okay, based on the input number of selection lines, you will write the truth table, right? Based on the truth table, you will get the output expression, right? So, what will be the output expression here? Can you tell? Suppose selection line is S here, A and B are the inputs. So, what is the output expression? S bar into
S
A
bar into A,
A
plus
bar.
S into B.
S into B.
So this is the output of multiplexer. Okay, so how can you design using the gates here? Suppose for S there will be a NOT gate and there will be A inputs given to the AND gate, and here S before the NOT gate there will be one AND gate given to, both are given to one OR gate. This is nothing but output, right? So by using this gate level modeling you can write this program. Otherwise, there is a very simple model by using the array model, which can be write in a single line. You can use any model. Okay. So here NOT gate. So output of NOT gate is S bar and input of NOT gate is S. So same thing we have written for NOT gate. And second AND gate, input is like in one. Here we have taken input as a S bar is another input, in one is the output. Okay, next for gate 2, B is the input, S is the input, in 2 is the output, and this into and this into in 1 both are connected to one OR, which is declared as a while because of interconnection between two gates. Okay, so like that we can write the multiplexer using gate level. And then by using this instantiation of multiplexer, and then by using this name of the multiplexer we can take instantiations. So mux 2 1, name of the mux is m1, a of 3, a of 2, s of 0, in of 1. Okay, better just take, suppose this is one 2x1 multiplexer, it has two inputs, and another 2x1 multiplexer, two inputs, one selection line. Both outputs will be connected to another multiplexer. Here output, here is another selection line. So here a of 3 is the input, a of 2, a of 1, a of 0, like that. In 1 is the output, in 2 is the another output. Both are inputs to this 2x1 multiplexer. Same thing you need to write. A of 3 is the input, A of 2 is the input, S0 is the selection line, in 1 is the output. For second multiplexer, A of A of 1 is the input, A of 0 is the input, S0 is the input, in 2 is the output. For third also same. In 1, in 2 are the inputs, S1 is the selection line, out is the output. Okay. Have you understood? Clear?
Yes, ma'am.
Okay.
Yes,
So,
ma'am.
so for this you can write a truth like a test bench. If you see here, A equal to 1010, selection line 00011011. Okay, we'll do the simulation. This is just a 4x1 mux using 2x1, like that. Write for 16x1 mux. Okay, using a small multiplexers, whatever you want. Okay, see the output here. If selection line is 00, whatever the data is there in here, the data get assigned, because we are taking a 3 first. If you take A of 0 first, then this 0 bit will get assigned, but we are taking A of 3 first. Okay, so that's why the third bit is assigning to here. If selection line is 0 1, this second bit. If selection line is 1 0, this bit. If selection line is 0 0, this. Okay, So this is how we can write hierarchical multiplexers. Clear? Have any doubts? Complemented. For every 20 time unit, selection 2 will be complemented. Okay, just in a 3 steps, you can get all the combinations of here 8 combinations. Okay, so at 5 time units, 5 time units, 5. Okay, at every 5 time unit, selection line is complement. So 0, 1, 0, 1, 0 selection line. For 10 time units, 1 will be complement. Initial, it is 0, next ones, zeros, next ones. For every 20 time units, it will be complement. For all, it is 20 time units, next all ones, next again 20 time units, it complement. Like that, if you want to generate for like that, if you want to generate for 16 bit, for every 40 time units, it should be complement, like all zeros up to 8 and again all ones. Okay, so this is how you can take using always block simply. Okay, see here, what is the input? Input is 1. So initially you have to initialize with this value. If you don't initialize with this value with the 0 0, how can we take the values, right? That's why you have to initialize all selection lines with a 0 first of all. Then it will do the complement accordingly. Okay, so initially it is 0. So if selection line is 0, whatever the input is there, that input is get assigned at the first line. If selection line is 1, whatever the input is there 1, it should get assigned to the second line. Like that you will get the answer. Okay, this is about the demultiplexer. Okay, have any doubts? Like that hierarchical demultiplexer, whatever we did for hierarchical multiplexer, same as you need to do for hierarchical demultiplexer also. Okay, clear? Have